All right, here we go. Eyes up. Let f and g be these two functions. F of x is this, g of x is this. Let r and s be the two regions enclosed by the graph. See the figure above. Today we are doing area and volume. So this is familiar to what you've seen before. I think you will like these problems better than what you saw yesterday. Okay? So the first question is find the sum of the areas of regions R and S. So I'm going to do R plus S. How do I do it? Integral. Okay? Integral of what? Find the area of R and the area of S. Top minus bottom. Which one's on top? F of x or g of x? How do you know? Should we graph them on our calculator and find out? Okay. Darren is correct that the one on the bottom at first is G. Let's just type them in because we're going to have to use them anyway. And I'm going to just do a little trick here, and I hope you guys are okay with this, but I'm actually going to put them into Y2 and Y3, okay? And I'm going to do 1 plus X plus E to the X squared minus 2X. And then I'm going to put X to the fourth minus 6.5x squared plus 6x plus 2. And I'm going to zoom standard. And so I'm going to watch. So it looks like the original assumption isn't correct. It looks like what looks like the cubic is actually the quartic. So this thing is g of x, and this is f of x, and this is f of x, and this is g of x. I'm going to zoom in with a box so I could get a better picture now that I've appropriately labeled them. This is a calculator problem. And now I get a picture that's very similar to what I've seen on my screen there, okay? So using f of x and g of x, can somebody tell me a little bit more about this integral? What do I do? G of x minus f of x dx plus f of x minus g of x dx. Great. So where does my first bound start? 0 and 0 to something. How do we find that something? Okay, second calculate. Intersect. First curve. Whatever, as long as I get close to the intersection point, it'll do its work. I'm going to write this out, 1.0328319. Now I'm going to call that x sub 1. That way I don't have to rewrite it all the time. So as long as I make that note, then I can just write x sub 1 here and x sub 1 down there. I can't. This one requires use of graphing calculator. Oh, I can answer that question for you later. But yes, it would take a long time. So what do I got there? What to then what bound? To 2. Okay? Now, now maybe you'll understand why I put my calculator the way I did. First of all, my window, I want to go my y minimum, not down to 0.3, but to -2. That way I can see the x-axis. That's going to help me out as I look at this area piece. but I want to do g of x minus f of x, okay? And we said that g of x is the quartic one, correct? So as I go into my calculator, I like this option, and I go into y equals. I'm going to take off the equal signs here, but I'm going to use those two. So I want to do y sub 3 minus y sub 2, right? So you could either just retype everything, or you could go variables, y variables, function, y sub 3 minus variables, y variables, function, y sub 2. And you can see that I now have exactly what I placed in here on my calculator. Well, you saw a shortcut? And so I go graph or second calculate, and number 7. And so I'm going to go my lower limit at 0. I'm going to do my upper limit at 1.032839. For these problems, I go all the way out just to make sure my area comes out as close as I can be. I'm going to round to 4 decimal places here, 0.99743. 0.99743. So I went 5 decimal places there. Just make sure that my rounding isn't going to be off at all. For my next one, so how would I change this in my y equals? y2 minus, or I could just insert a negative sign and then make that positive, correct? So again, I'm just about saving time and trying to be efficient here. Okay, so I'm going to go to second calculate. Number 7. Again, the region should be above the x-axis because area in this situation is defined as positive. So looks like it should work out. I've got 1.03, help me out, 2, 8, 1.006919. So I'm going to take and add those two values together. 1.0069 plus, and we've got 0.99743, and our final answer just needs to be within 1,000, or yeah, it needs to be rounded to 3 decimal places. So 2.004. If you want to write the other one on, you sure can, or you can leave it off. Everybody okay with that? All right. Problem B. This is new. This is where you really need to focus, and this problem is not that bad. All right? It says that you are going to take region S as the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. So what's going to happen is you are going to cut this thing like this, okay? And as you cut it, okay, you get a slice, okay? And this is the bottom, but the top, it has 3 dimensions to it. It's actually coming out at us. It's a square. So here, the square has a very small height. It's only coming off the board a little bit. But here it's coming off the board, a few inches. Okay, up here it's just coming off the board a little bit. You see that? So basically what we have is I'm going to try to draw it, and I'm going to be really bad at it, but I'm going to try to do it. Okay, thank you. Thank you, Wally. So we have this kind of 3-dimensional shape going here, okay? First of all, its width is dx. Okay? What's the height? How do you calculate the height? F of x minus g of x. And if it makes a square, then what's this dimension? What's the dimension that comes out the board at you? It's the same thing as this, right? F of x minus g of x. So what's the volume of that shape I drew? F of x minus g of x quantity squared times d of x. And that's one of them. So I have the integral of f of x minus g of x, that quantity squared dx. And where's my starting point? Yep, x sub 1, and I'm going to go to 2. So I'm going to go into y equals, and is that f of x? Y sub 3 is g of x, isn't it? So I got to, okay, so this is right then. So this is f of x minus g of x. So I'm going to insert a parenthesis and a parenthesis, and I'm going to square that beast. And now I'm going to calculate number 7. And I'm going to go from 1.03, help me out. I'm going to go up to 2. I love that. It never gets old. 1.28316, whatever. Who cares? Just go past 3 decimal places, you're fine. Or cut it off at 3 or round to the nearest 1,000. Okay, those are your options. So that looked like a super complicated problem, didn't it? But it's not that bad. They always do it where they say, well, this shape is the base, this region is the base, and then you got something coming off at you. And it could be a square, it could be a triangle, it could be a semicircle, it could be a lot of different things. And we just got to make sure we can find the volume of it by thinking about the drawing. And we'll do a few over the next couple days. Okay, so let's do the last one. Let h be a vertical distance between the graphs f and g. Okay, well, this would be the vertical distance. Agreed? All right. Find the rate at which h changes. What does it mean to find the rate at which h changes? H prime. Well, what is h? How do we even find h to begin with? Yeah, it's just the top minus the bottom. F of x minus g of x. That's all it is. So if we want to find h prime, we just find the derivative of that, right? So f prime of x minus g prime of x. And we use at x equals 1.8, apparently, is what they want. Well, so I just go to my calculator, and so I'm just going to verify again that I have this correct. So f of x is my y sub 2 value. This is my y sub 3. I'm going to go to my calculator. I have, yep, so I've got a negative g, so I have f of x minus g of x, so I've got that. So how do I find the derivative of 1.8? So I can calculate 6. And I do, did I even do it? So I can calculate number 6. 1.8. dy, okay, negative 3.811. 812. I'm going to pause this and look up the scoring guide. All right, here we go. Another calculator problem. Let region R be the region enclosed by that and the horizontal line y equals 4. So I've got y equals 4, and I've got y equals f of x. which is that x to the fourth minus 2.3 x cubed plus 4. And it says, start by finding the volume of the solid generated when r is rotated about the line y equals negative 2. Ugh! Holy cow. So I've got like, that's the region. I'm going to rotate that around negative 2. Yeah. Get something like that. So we start with the area. Would you draw vertical rectangles or horizontal rectangles? Vertical. And I'm going to flip that rectangle around. Do I get a disc or a washer? Why do you get a washer? Yeah. So let's look at this washer right here. This is y is equal to negative 2. This part right there is what? What makes up the inside of that washer? Yep, y is f of x. What makes up the top of the washer? Y equals 4. So what is big R? 6. What's little r? F of x plus 2. So if I want to find the volume of one of them, I've got pi times big R squared minus little r squared dx. So pi times the integral of, what is big R squared? 36 minus f of x plus 2 quantity squared dx, right? Bounds. Zero to something. How do we find that something? Calculator. Okay, let's go to our calculator. So I'm going to go to y sub 2. I'm going to go x to the fourth minus 2.3 x to the third plus 4. And then y sub 3, I'll make that 4. I'm going to leave y sub 1 open. Zoom standard. And I've got to find the intersection point. So second, calculate number 5. I'm going to go close to that intersection point. Right about there. And I get 2.3. Cool. So 0 to 2.3. So in y equals, I'm going to take off that. I'm going to take off that. And here, I'm actually going to put what I'm going to calculate. So I'm going to put 36 minus parentheses where I type in f of x. Yep, I typed in a y sub 2, so variables, y variables, function, number 2. It's y sub 2 plus 2 squared. And I'm going to calculate number 7. It should be positive the entire time from 0 to 2.3. And I get 31.47. That's the mistake I made. I got this problem wrong on when I did it last hour. I wrote down 31.47. So 31.4706 as my answer. And that's wrong because you got to multiply by pi. And I forgot to do that. So you could just leave it as pi, or you can multiply it out. Leave it to Jake to always correct us. Nice job, Jake. I don't give packets anymore. Just book assignments. All right, B. B says region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. So I've got this piece, and as I draw it out, I've got that left over, okay? So what's going to be this dimension right there? 4 minus f of x. What's going to be this dimension right here? Why is it 4 minus f of x as well? It's isosceles right triangle, so the legs have to be the same. So how do I find the area of that triangle? An area of a triangle is base times height. So we have 1/2 times 4 minus f of x times 4 minus f of x, right? So squared. And we're going to integrate from 0 to 2.3. So I take out my calculator. Y equals. So I'm going to get rid of all this stuff. And I'm going to go 0.5 parentheses 4 minus, we got what? Y sub 2. So variables, Y sub 2, parentheses squared. And I'm going to calculate from number 7. Zero, 2.3, and I get 3.5737. Am I recording? Yeah. All right. So I've got 3.5737. What do you think about that? Not too bad, huh? As long as you see that little trick about how to set up those other pieces. Why don't you move when I tell you to move? Move! All right. So let's do C. Last problem. And I'm going to need a volunteer. Thank you, Jake. All right. So it says that we have a vertical line, x equals k. So I'm going to draw a vertical line here. Okay. And it says that the vertical line x equals k divides R into 2 regions of equal area. You tell me when you think I've put it so that it's 2 regions of equal area. Okay. All right. Are you ready? Are you ready, Jake? Okay. All right. Jake, come on. God, what? There? No, that's not even close. All right. All right. Okay. That's about it. So he's saying that this is a k value right there, x equals k. And it wants us to write an equation involving an integral expression whose solution gives you value k. Now, I want to be clear about this. This sounds like a really complicated problem. It's really not that bad at all. The first time I did this problem, I was at the AP Institute, and everybody got the problem done pretty quickly. And I took a long time. I was like, I felt like I was stupid because everybody else was working. You know, they were done, and I was like, I'm not done yet. I was trying to figure out how they did it so quickly. And I actually found K, and I wrote a very much more complex equation. They want this to be pretty simple. We want to write an area for that and set it equal, because it says equation, equal to the area of that. That's it. So the first area would be from where to where? 0 to k of, what's the top? 4 minus f of x dx. That's the area of the first region. Equals k to 2.3 of 4 minus f of x. Whoops, sorry. I'm sorry, I was thinking ahead to my next part here. So we got k to 2.3 f of x dx, right? So they will give you full credit for that. What I did was I said if you double this area, okay? Now how did I say that? I'm trying to think of how I did the problem. I think I subtracted them and I set it equal to 0. And then I actually found the antiderivative, plugged in k, and solved for k. But whatever. You don't have to do all that. So let's check the scoring guide. Okay. So, yeah, maybe this is it. Maybe it's not. That's probably it. There we are. Okay, we've got it. And we have a zoom option here. No zoom option for Wally. Sorry, Wally. So the first one, it says that you should be at, first of all, it gives you 2 points for the integrand, or the integral, as you set that up. So 0 to 2.3. Gives you 1 point for finding the limits of 0 and 2.3. Okay. Setting f of x equal to 4 on your calculator. You come up with 98.868, which is 31 pi approximately. So we did good there, right? Yeah. The next one, you can see the 1/2 of 4 minus f of x quantity squared, dx, which we came up with the 3.57. And they give you 2 points for setting up the integral correctly, and then you get 1 more point for the answer. Again, it generally goes if you don't get the first couple points, there's no way that you get the other couple points. In this situation, the limits, they would give you a point for that at least. And then the last one, we set it up exactly like they had it, right? There's a lot of different equations you could set up. Yeah, maybe that's actually what I did. I can't remember but yes, that'll be another one. So you could set up and say it's equal to 1/2 of the whole area. Yep. Yeah. So lots of options there. Okay. Yes. Doesn't matter. The 31 pi that we had is absolutely acceptable. But I forgot to put the pi there. So I got the first 3 points, but I did not get the last one. So today I was 9/9, and I was 8 out of 9. So you get some points off every once in a while. It's okay. We all make mistakes. All right. You guys want your assignment? Do number 4. So again, you won't hand this in, but what I'm asking is that you attempt problem 4 tonight, that you would score yourself and see how you do. And tomorrow, we will show you how to do it. I'll do one more, and then you have 2 problems for homework. Got it? All right.